What is the best method to solve a system of equations? We've talked about graphing, substitution, and elimination, and I'm going to kind of take you through all three here in an example problem to figure out which way do you think is the best. So here's the pretend situation. Mr. Donnelly and Mrs. Rogers are having a bake sale to raise money for a PS5. Mr. Donnelly sells 11 brownies and 5 cakes for a total of $72. Not even close to enough money. Mrs. R sells 7 brownies and 13 cakes for a total of $144. So they didn't make enough money, so let's think like, okay, well, maybe they should have charged different amounts for the brownies and the cakes. See if that would have affected that would have obviously increased the money they made, but let's kind of figure out, what did they charge? How much was a brownie? How much was a cake? So we can create a system of equations and figure out the cost of one brownie and one cake. X is going to equal the cost of one brownie, and Y is going to equal the cost of one cake. And we need to come back to this at the end to kind of remind us what this does. So the first thing we're going to do is we're going to solve it by graphing. And to graph it, we will create a table. So I created a table and I put X values of 1, 2, and 3 here. That's all I ended up needing. And I put the Y value for Mr. Donnelly and the Y value for Mrs. Rogers. So if X is 1, Mr. Donnelly would, so if X is, that means the cost of brownie was $1. I'd have to charge $12.20 for a cake. Mrs. Rogers would charge $10.50. So now I have two sets of ordered pairs, one $12.20 and one $10.50. For $2, it would be $10 for both of us. So that's where we'd be the same. This is going to end up being the solution. I've stumbled across it. X is $3, Y would be $7.80, and Y would be $9.46. So I took these ordered pairs and I plotted them and made the graphs for me and Mrs. Rogers. They intersect at 2, 10, and so that's my solution. So graphing is pretty straightforward and easy if I can set it up. If you have a system like a Desmos or a graphing calculator and I can find the intersection point, it's pretty easy in this case. So this might be the best way to do it, graphing and finding the intersection point. That being said, we can do the substitution method. In this case, I thought it was kind of laborious to do because I made a mistake the first time through. I had to go back through and rework this before I made the video. But Mrs. Rogers' equation, my equation, I took my equation and I isolated y. So I got y equals 14.4x and 14.4 minus 2.2x. I went back and substituted that y value into Mrs. Rogers' equation. I multiplied out 13 times these numbers. I ended up with these bigger numbers that are decimals. I had this weird negative x, negative 21.6x plus 187.2 minus 187.2 equals 144 minus 187 and 2/10. And then I divide both sides by 21 by negative 21 and 6/10. Did that on both sides here. I end up x equals 2, which is right. If I substituted that back into either one of the first two equations in the system, I got y equals 10, so I got the same solution, but it was a lot more laborious than graphing it. So graphing, I think, was easier than substitution. But then we come to elimination. And elimination, I didn't think was that bad. Once I practiced this and really got the hang of it, it wasn't too bad. I thought this was all right. So what I did is I had my two equations. I looked at the coefficient here. It was 11. So I multiplied the other equation by the opposite of that, negative 11. And then I took that same x coefficient and I multiplied the first equation by 7. So 7 gets multiplied up here, and then the opposite of this gets multiplied down here. I multiplied through, end up with negative 77x, and negative 77x equals 0. I got 7 times 5y is 35y, and negative 11 times 13y is negative 143y. So I ended up with negative 108y. 7 times 72 is 504. Negative 11 times 144 is negative 1,584. These are big numbers, but I used a calculator, so it wasn't like that big of a deal. I added these two numbers together. I got negative 1,080, and then I divided it by the negative 108y, and it ended up equaling 10. So y equals 10. At that point, I knew that I had gotten the correct solution for y. And so I took that 10 and I substituted it back into one of the original equations. 11x plus 5 times 10 equals 72. 11x plus 50 minus 50 equals 72 minus 50. 11x divided by 11 equals 22 divided by 11x equals 2, so I got 210. And so it's a matter of kind of like thinking back at your work and figuring out what's the best method to solve a system of equations. I think graphing to me was pretty good for this one, especially based on having electronic resources, but even drawing the graph out by hand. And it's just going to depend on each problem. So practice and figure out which way you think is the best and what you're the best at.